we want to investigate the relationship between the concepts of a random sample and a simple random sample. We will find that the simple random sample is a much more restrictive condition and is much more difficult to satisfy than simply a random sample. So let's start with a population that contains some capital N members, and we want to survey this population. So the straightforward way to do it would be to survey every member of the population. However, with a large population, this is not feasible. So what we do is we take some sample, subset of the population, and we survey the sample that we have selected. And then we are entitled to project the results of our sample back onto the whole population as long as the selection of this sample was done by a technique that qualifies to be a random sample. Now, the definition of a random sample is that every single individual in the population had the same probability of being chosen to be in your sample. This is, in practice, not too difficult to satisfy. There is a more restrictive type of sampling technique strategy that you can use, which is called a simple random sample. And it means that the sample that you have selected could have been any sample in the group. That is, every sample of the same size in the entire population had the same probability of being chosen by you to be the sample in your study. Every single sample of the same size as the size of the one that you have chosen had the same probability of being selected by you for your sample. So let's see a condition that will illustrate the difference between the two. Let's take a classroom, and let's suppose that the classroom has 16 students. 1, 2, 3, 4, 5, 6, and over here 1, 2, 3, 4, 5, and 6, and here 1, 2, 3, 4, 5, and 6. So the size of the population is 18. And we want to take a sample size of 6. So if we put all of the names of all 18 into a hat and shuffle them up and pull out 6, then except for the fact that there are some different size names going into the hat and small nuances like that, then every single member of the class had the same probability of being chosen to be in our sample of 6. And that probability is easily found. If there are 18 students, that's a total number of cases, and 6 would be favorable. So the probability of any single student being chosen in this type of very random technique is 1/3. And therefore it qualifies to be a random sample. Now, a simple random sample, it would also qualify to be, because no matter which 6 that we chose, this 6, or I'll just do some checking right here. Suppose I choose this 6 right here, and this one, then this had the same probability of being chosen as this one right here. 1, 2, 3, 4, 5, and 6. So every grouping of 6 in the whole class, if we use this strategy of putting them all into a hat and drawing out their names, have the same likelihood of being a chosen sample. So our technique then did yield a simple random sample. So again, the terms random sample and simple random sample judge the technique or the strategy of your sampling. Now, I'm going to illustrate a different sampling strategy or technique that would qualify to be a random sample, but would not qualify to be a simple random sample to make the difference. Notice that the students in the class are seating in 3 rows, row 1, row 2, and row 3. Now, what I'm going to do is to put the numbers 1, 2, and 3 into a hat, and I'm going to pick out one of those numbers, and the number that I pick out, then that row will be my chosen sample. So I will also get a sample of 6 students. Now let's ask, what is the probability that any one of these students is chosen into that sample? Well, if they happen to be in the lucky row, then they're chosen. If they're not in the lucky row, they're not chosen. And there's 1 lucky row and 3 rows, so again the probability of any student being chosen is 1/3, just like it was before. And every student in the whole classroom has exactly that same probability, 1/3. So it does qualify to be a random sample. So now let's ask the question, does it qualify to be a simple random sample? If indeed it does so qualify, then every group of 6 in the whole class must have had the same probability of being chosen as every other group. And you see, immediately it does not qualify at all, because I can take a sample group of these 6 right here. And with my strategy of selecting 1 row, what is the probability that this group of 6 would have been chosen for my sample? Absolutely 0. Or let's take this group right here. 1, 2, 3, 4, 5, and 6. What is the probability that that group would have been chosen for my sample? Also 0. So you see, not every group of 6 in the entire population has the same probability of being chosen for your sample when we use this technique. So therefore, this technique does not qualify as a simple random sample, even though it did qualify for a random sample. So it's much more difficult to satisfy the criteria for a simple random sample. In fact, our usual sampling techniques of stratified, cluster, and systematic, if you think about them, are certainly not simple random sample techniques. The reason that we use them is because a simple random technique sample is so difficult to achieve in actuality, it's just not possible in practicality. But we are satisfied by the fact that they are, all of those, stratified, cluster, and systematic, are actually random samples.